Yeah, read the question.
The acceleration due to the gravity on the Earth's moon is 1.6 meter, meters per second squared. If an 70
Wait, wait, wait.
kilometers,
Wait,
75
wait, 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 wait. You just now said kilometer. Whoa, 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 whoa,
kilograms, 75 kilogram
whoa.
astronaut
Whoa.
walks on the surface, determine its mass and weight.
First of all, does mass ever change?
No,
No, and the SI unit for mass is what?
the kilogram.
Right. So the mass is 75 kilograms. Mass is the amount of matter our body possesses that never changes. Right. Part two. It's weight. Now, Isaiah, help me with this one. So, Isaiah, weight changes, right? It depends on the gravitational force acting on our body. The more gravitational force acting on our body, the greater the weight is going to be, right? Because weight is a force by virtue of gravitational, by, by, by virtue of the gravitational acceleration, right, Isaiah? So, if you're on a planet and the gravity is more, then you will exert a greater force on the surface you're standing on. So, Isaiah, do you remember the formula for weight?
It's mass times gravity.
Right? W is equal to mass times gravity. What's the mass?
25 kilograms.
How come you sound like you're underwater? You're using a different mic today?
Yep.
Okay. So the mass is 75, right? And the gravity they gave it to us. So did you have a hard time realizing that the gravity there would be 1.6 ms minus 2? Or did you know that was the gravity?
I knew that was a gravity.
Right, because because of gravity, objects would accelerate towards the center of the body. Take for instance, Earth. You drop something, an object would accelerate towards the center of the Earth. Obviously, be stopped by the ground, right? So 75 by 1.6. What did you guys get? 75 by 1.6. Tell me, guys, what did you all get?
I got 120 newtons. Oh,
Right, 120 newtons is correct. Cool. Question 9. Let me do question 9 fast. The acceleration, fast. Do that read.
the acceleration due to gravity on Earth, which is 9.8 meter, well, 9.8 meters per second squared. A trailer has a mass of 3,000 kilograms. Each wheel of the trailer is able to exert a maximum of 5,000 newtons of reaction force. Calculate the minimum number of wheels the trailer should have.
Right. So this was a tricky question in the sense that when you found the number of wheels, if there was a fraction, you'd have to round up. Because obviously you can't have a fraction of a wheel, right? Otherwise it wouldn't be a circle. That would kind of defeat the purpose of it being a wheel. So Shay, walk me through how you did this question.
Um, I basically found like the total force and
Mhm.
then divided it by the force for each wheel to find out how many wheels required.
That's
And by
correct. Yeah. And what did you get for your answer?
I got approximately 6 wheels, 5.88.
Well, let's see if that's correct. So gravity on Earth is 9.8 meters per second squared. The trailer has a mass of 3,000 kg. If that's the case, then the force exerted by the trailer would be given by weight is equal to mass times gravity. The mass here is 3,000 kg. Gravity, because of Earth, is 9.8, right? 3,000 by 9.8 is 200, I mean 29,400. 29,400 newtons. In physics, if you leave out a unit, you lose marks, right? Calculate the minimum number of wheels the trailer should have. So, Shay, if each wheel is capable of 5,000 newtons of reaction force. And Shay, do you understand what they mean by reaction force? Or you don't know what that means? Reaction force. Tell me, Shay, do you know what reaction force means?
Isn't that like just the force exerted by whatever?
Well, you see, weight always acts in one direction. Tell me, Shay, like either up or down.
It will be down.
Right, down, because and you know this saying, it weighing me down. Yeah, weight is a downward force. And so remember Newton, do you remember Newton's law of motion? The three laws, one of them would have said that for every action is an equal or opposite reaction. So if weight is acting downwards, then you would need a opposite reactive force to keep the trailer stable. So that's why it's called reaction force, because it would react to the downwards force and act upwards. So if you want to figure out the minimum number of wheels, first of all, you'd have to find the number of wheels. And to find the number of wheels, it would be equal to 29,400 all over 5,000. Because we are trying to see how much wheels it would take to be able to hold up this 29,400 newtons of force. When you plug that into your calculator, you should get 5.88. But Isaiah, can you have 0.88 of a wheel?
No.
No, so that's 6 wheels. So guys, these questions were extremely easy, right? No trouble at all. All right. Shay, the question was easy, right?
Yes, sir.
Okay, great. All right, so a lever. A lever is a type of simple machine. Machines are designed to make work easier, which means that they can either modify or transmit forces and motion, or number two, convert different types of energy into mechanical energy. So Shay, read the part about all machines have an input and output.
All machines have an input and an output. The input force is usually referred to as the effort, and the output force is as the load. Levers have a point of rotation, and these forces will turn about. The point of rotation is referred to as the pivot or the fulcrum.
Right. So would you all say that a seesaw is an example of a lever?
Yes, sir.
Yeah, and where would the fulcrum slash pivot be?
That'll be in the middle where like it moves. Well, yeah.
Yeah, right? Cool. Right? The greater the distance from the fulcrum, the greater magnitude of turning force. I need you all to copy this down at least. So under levers, copy down the greater the distance from the fulcrum, the greater magnitude of turning force the effort would have. Do you know why that is, Shay? You know what the formula for turning force is equal to?
No, sir. But I know like if you increase the distance, it's like easier to like pull from common sense, but like not the actual.
Right. From
There's
common sense, it
force,
makes sense, right? Isaiah, you're saying something?
there's force times 3 perpendicular distance from the pivot.
Shay, you hearing what Isaiah saying, boy? Shay, is it just me hearing Isaiah kind of weird, like real muffled?
Yeah.
Isaiah, I think you meant to say force by perpendicular distance. So the moment is equal to the force by the perpendicular distance, as we want to say.
You
Shay.
just type that in, yes.
Okay, great. So Shay, obviously the force is the force that you will be exerting, and the distance will be distance, the perpendicular distance from the pivot, which is the turning point. So that's the actual formula there. So you can imagine, because it's multiplication, if you increase your distance, what would increase? The moment, right?
Yes.
Yeah. Right? So we refer to the turning force as a moment or as a torque. So I would like you guys, let me tell you what to copy down, right? Obviously, it don't make sense to copy down everything because it just take way too long. Right? Makes work. Yeah. So the input force is referred to as the effort, right? And the output force is called the load. Point of rotation. This is called pivot or fulcrum, right? Yeah, so essentially copy down everything I have in red. So you'd have levers, make work easier. Then you would have number one, it could either modify or transmit forces and motion or convert different types of energy into mechanical energy. Then input force effort, output force is load. Then put point of rotation is referred to as a pivot or fulcrum. And then the greater the distance from the fulcrum, the greater magnitude of turning force the effort would have. This turning force is sometimes referred to as moment or a torque. And then I'd like you to write the formula for that, right? Right? So the formula, like I said, was M is equal to force by the perpendicular distance, right? Where M is the moment, F is the external force applied, external force, right? And D is perpendicular distance from pivot. So Shay, you're probably hearing this talk about perpendicular distance, but why exactly am I saying perpendicular? Do you know why?
Is when it like when you hold the like on a seesaw, when it's like straight across, it's like perpendicular to the ground. Like I don't know how to explain it. Like I know the diagram and stuff, but I don't know how to explain it.
I'll draw a diagram. Yeah, it sounds like you understand it. So essentially, I just want you guys to copy down the main points. You gotta copy down everything, right? So as soon as you have that copy down, let me know. All right, Shay, nearly finished copying down the main points.
I just finished everything.
Okay, Isaiah, nearly finished copying down the main points.
I'm done.
Okay, cool. So as you could see, all right, so Shay, check this out. So in this particular question, where do you think the pivots would be? Do you think it would be over here, or where do you think the pivots would be? Tell me, Shay, where do you think the pivots would be? Do you think this is the pivots? Shay,
I think the pivot would be where the screw is.
over here?
Yeah?
Yeah, because when you exert a force downwards, right? Wouldn't it turn about this point? Yeah?
Yes, sir.
And as you could see, when you apply the force, wouldn't it be perpendicular? Two things. When you apply the force, right, Shay, isn't it perpendicular to the moment arm? You can see that,
Yes,
right?
sir.
And additionally, when we draw the diagram for the seesaw, you'll see why we say the perpendicular distance. But basically, Shay, the reason why we say perpendicular distance is because you apply the force in a perpendicular distance from the pivot. Watch, if this is the pivot and this is the force, this distance you're measuring is actually perpendicular to the pivot. You'll see what I mean just now. Right? There are three classes of levers on the diagrams below. Label the effort, load, and fulcrum, and determine which class of lever each is. So the first class is fulcrum between effort and load. The second one is load between effort and fulcrum, and the third is effort between load and fulcrum. Isaiah, did you ever do this before in school?
Yeah, in Form 3.
In Form 3? Okay. Shay, yeah? No?
We did it in Form 3.
Okay. So, Shay, the first one, they're saying it's first class, but why? So the fulcrum is between the effort and the load. So remember, Shay, the fulcrum or the pivot is where the rotation happens about. Right? The effort is where you are applying the external force, and the load is what you're trying to move. So can't you see that you are applying the effort over here? It's going to pivot about this point. So like depending on how much force you apply, wouldn't this move? Wouldn't this rotate about this point?
Yes, sir.
And it'll move the load. Cool. They're saying that this is second class, but why?
Because it loads in the middle.
Exactly, the load is in the middle. You place the load over here, right? And well, this will be the fulcrum or the pivot because you can imagine that if you have a wheel, you could, if you apply a force here, wouldn't the wheelbarrow tilt up or tilt down? You can understand what I mean?
Yes, sir.
Right? And let's do one third class now. So this kitchen utensil is an example of a different kind of lever. And I'm gonna explain why. See, wouldn't you be applying the force over here and that would clamp whatever you have, wherever you put in the middle?
Yes, sir.
Yeah. Now, again, the greater the distance from the pivot, right? The greater the distance from the pivot, the greater the force would be at the load. So, Shay, wouldn't this kitchen utensil like pivot about this point? So you'd apply external force on either side and it would rotate. It could freely rotate about that point, and once you apply a force here, it would grasp something. So I think you understand this, right? The different types of levers. I've never seen them bring this in the exam before, but it's good to know. Isaiah, did you ever do any past paper questions asking you about the first, second, or third lever?
No.
Nah, yeah. This doesn't come at all, really. Right? I'm not sure what happened there. As soon as you all see back the screen, tell me, right? As soon as you all are seeing the screen, tell me. Are you all seeing the screen?
No, sir.
That's weird. So the main thing I want to move on today is I want to move on to moments. That's the main thing I want to move on to today. If this thing will work. Okay. I presume you guys are seeing the screen now.
Yes, sir.
Cool. So let's look at principle of moments here. And this is the part where I'm going to explain what they mean by distance perpendicular to the pivot. So shape, let's just say that we have a seesaw over here, right? We have a seesaw. Wouldn't there be forces acting down on the seesaw?
Yes, sir.
But to keep the saw in equilibrium, wouldn't the pivot have to be exerting an upwards force perpendicular to the moment arm? Or am I confusing you?
Wait, can you repeat that?
All right, Shay. So you understand that if if someone sits on the seesaw, they would generate a downwards force. Yeah.
Yes, sir.
Now, if I want to keep the seesaw at equilibrium, wouldn't I need the pivot to be exerting an upwards force? Yeah.
Yes, sir.
Yeah. And if this is 1,000 Newtons here and this is 500 Newtons over here, then this at the pivot would have to exert an upwards force of 1,500 Newtons to make sure it's at equilibrium. Now, Shay, I want you to observe something. The force at the pivot would be perpendicular to the pivot, the moment arm. Can you see that? So the upwards force here would be in this direction. You can see that, right?
Yes, sir.
So any length I measure away from the pivot, it would really be what? I think you could see what I'm talking about there. It's really what? If I measure a distance, say this distance over here, it would really be what to the pivot?
The perpendicular.
Right. And that's why we say distance perpendicular from the pivot. Right. So the drawing depicts OD trying to balance Garfield. Who is heavier? Let's also say that two of them are at a balance or equilibrium. How far would OD have to be from the pivot to balance Garfield? Now, Shay, we just discussed that if you want to generate a greater moment, you would want to go further away from the pivot. That's the truth or that's a lie?
That's the truth.
Okay, so who's heavier over here? Who's heavier?
I'll say Garfield.
All right, because Garfield always stuff in the face. Oh, you know who Garfield is?
Yes, sir.
Okay. So if Garfield is heavier, that would mean that OD has to go a greater distance away from the pivot to cancel off with the moment created by Garfield. Isaiah, does that make sense?
Yeah.
Yeah? Okay. So let me go on to a new page and I'll make some notes about it. Now, if a system, right? So you all could copy this down as principle of moments. This is a new heading, principle of moments. Principle of moments. And there are two main things you need to know. If a body is in equilibrium. Shay, do you know what equilibrium means?
The thing that allows for like the forces to be balanced.
Yeah. So, if it wasn't balanced, then and there would have been some slant.
Yes, sir.
Yeah. So if a body is in equilibrium, two conditions must be met. Number one, the downward forces need to be equal to the
Upward force.
right. Downward forces has to be equal to the upward forces. Right. Number two. So Isaiah, if you are applying a force with reference to the pivot, you're going to create a turning force, which is called the moment. So if that's the case, Isaiah, wouldn't there be two kinds of moments? Think about it, Isaiah. If you were to exert a force on this side, wouldn't it cause the swing to move in this direction?
Yeah.
So what kind of direction is this? Clockwise or anti-clockwise?
Clockwise.
Right? So and shape. If you were to go on the other side of the pivot and apply a force, that would cause the seesaw to slant in this direction. And the greater the force, it will keep turning. So this turning force is clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise. So there are two types of moments: anti-clockwise moments and clockwise moments. Right? So if a body is in equilibrium, downward forces need to be equal to upward forces, and the clockwise moments need to be equal to the anti-clockwise moments. And we should know by now that the formula for moment is equal to force by perpendicular distance. Now, shape. If you are at a distance of 0 meters from the pivot, so shape, in other words, if you are directly at the pivot, would you have a moment?
No, sir.
No, because look at the formula, it's force by distance, right? If the
If it
distance
have
is
no
0,
distance, it have nothing.
yeah, exactly, right? So you need distance to be able to generate a turning force. In other words, a moment. So I hope everybody understands that. You need to be some distance away from the pivot to actually generate a turning force, right? What do you all prefer? And what makes more logical sense? If I say turning force or moment, what do you all prefer? Because they're the same thing, but which one do you all prefer?
It doesn't matter to me.
Doesn't matter, okay. All right. So let's do this question over here. Actually, let me come up with a question. Right. So Shay, any of your friends on the chubby side? Like, in other words, if have any of your friends, like if you're gonna see some of them, would they like, if they sit down, would they throw you upwards? I think that's a no. Isaiah, what about you? You have any like chubby friends that are like kind of big? Maybe they sit down on a seesaw.
Yeah.
Yeah.
I was like 115 pounds, so I was skinny.
Oh, okay. That is quite skinny. Yeah. Guess how much I weigh?
Um, Around 150 to 170.
Well, you see, you see how easy it is to say say wrong terms. If I if I ask you, guess how much I'm weighing, and I say pounds, right?
Oh,
Is
it's nice
it
weight.
that
No, I mean mass, mass.
mass?
Yeah.
Yeah. So the proper thing to ask really is, can you guess my mass? Shit, you see how easy it is to say the wrong thing? And you see how, and shit, you can't tell my lying. And everybody just be asking you how much you're weighing. Nobody is asking you what's your mass.
Yes.
But mass is actually kg or pounds. That's mass. right? Okay. So Isaiah, give me one of your give me a name for one of your friends.
Paul.
Who?
Paul.
Paula?
No. Paul.
Paul?
Yeah.
Okay. Let's just say that this is Paul over here, right? Now he real big. That's not he head, that's he belly, right? Right. And Isaiah, how much do you think he weighs? Give me it in newtons. Or would you prefer to give me his mass first and we could find for the force? What do you think?
And the mass first.
Okay, what do you think? What do you think is his mass?
250 kilograms.
What? You know how heavy that is, right? You, Isaiah, you know how heavy that is, right? She, you know how heavy 260 kilograms is?
Yes.
That is 550 pounds. Isaiah, your partner is 550 pounds? Isaiah?
I don't think so.
Wait, okay, wait. Well, well. Okay, all right. Okay, and Isaiah, let's just say that this is you. And how much, what's your mass? What's your mass? Tell me, Isaiah, what's your mass? In kg.
Google say around 52.
Okay, 52. Wait, boy. She, this, she, you know anybody who weighed 500 pounds?
500 pound life.
Say that again?
500 pound life to show.
Yes, with Tommy and you know what I'm
I
talking
think it's
about?
600, but yeah.
Yeah. She really lose weight though. I think Tommy or something, and she really lose weight.
Yeah. She just had a surgery.
Yeah, I think gastric bypass or something. Some gastric sleeve or some surgery. But anyways, she, let me show you how we're gonna do this. First of all, we need to identify where the pivot is. So I think we could all see that this is the pivot, right? This is the pivot. Yeah.
Yes, sir.
Now let's just say that we don't know what's the distance between Paul and okay, I spell your name very wrong. Isaiah. I think that's it. Right? Yeah. So shit. Let's just say that we don't know the distance. Paul is standing away from the pivots. So let's just call that X meters. Isaiah, give me a distance for you. Give me a distance for yourself. Tell me, Isaiah. Give me a distance. Isaiah,
Um, 0.3.
23 meters.
No, 0.3. 0.3.
0.3. Nah. Let me just say, let me just say 1 meter. Okay. All right. So, let's look at this side of the pivot. Now, because Isaiah is standing there, by virtue of gravity, he will exert a downwards force, right? And this downwards force would cause the seesaw to tilt in this direction. Does that look like clockwise or anti-clockwise?
Anti-clockwise.
Right? So this is an anti-clockwise movement. I honestly love these questions. And obviously that's the anti-clockwise moment. Then if Paul stands on this side, then it'll generate a downwards force in this direction. And that would cause the seesaw to slant like this, right? So we're gonna call this clockwise moment. So Shay, in this question, what are we trying to find for?
X, the distance between Paul and the pivot.
Now, logically, Shay, before we do anything, conceptually, don't we know that X has to be less than 1?
Yes, sir.
Because if this system is in equilibrium, then Isaiah, you want to stand a good bit further away from the pivot than Paul, to generate that turning force to balance off with Paul, because he cannot find. So there's one more thing you have to do, right, Isaiah? You need to actually convert the mass to weight, right? To figure out the downwards force. So Isaiah, let's assume that gravity is 10. If gravity is 10, then it would have a force of what?
520 newtons.
Right? 520 newtons. And this would be a force of what? What shape?
2500. Oh, sorry.
Oh, okay, that's okay. 2500 newtons. Shit, did I lose you anywhere? Or you're good?
I'm good, sir.
Right? So remember what we said. For our system to be in equilibrium, it don't matter how you write it. You can write ACW is equal to CW, doesn't matter. Right? Once you're showing that they're equal. So ACW moments is equal to CW moments. Great. So the formula is force by perpendicular distance. So Shay, let's analyze here, right? What is his distance from the pivot, Shay?
1 meter.
And what is his force? What is the force he's exerting now?
520 newtons.
So it's gonna be 520 by the perpendicular distance by 1. Cool. And that's going to be equal to what, Isaiah?
520 newton meters.
Not so fast. That'll be equal to the clockwise moments, right? And the clockwise moments would be Paul. So you would say the force, which is 2500, multiplied by the distance, which in this case is x. We don't know what the distance is. Right? So we have to work this equation out. 520 by 1 is just 520. 2500 by x is 2500x. So guys, if I want to find for x, I would have to do what on both sides? I would have to divide by what on both sides? To find for 1x.
2500.
Yeah. Shay, I confuse you?
No, sir.
No? Okay. So plug that into the calculator and let me know what you guys are getting.
Zero 0.208.
Right? And if we run that off to 2 decimal places, that'll be 0.21. Right? And don't forget the units. What would the units be for this? How many units? Shay, what would the units be?
Meters.
Right, meters. So Shay, do you like the principle of moment questions?
Sure. They're fun and like in the term.
They're fun?
Yeah, and the term
I like that.
papers.
I like that. We hear what? By the end of today, we're gonna do a nice question like this, right? A past paper question. You're gonna like yourself. You're gonna love yourself. Matter of fact. Right? So what I want you guys to copy down is copy down principle of moments and make a note that if a body is in equilibrium, the downward force would be equal to the upward forces, and clockwise moments are to be equal to the anti-clockwise moments. Vice versa, it doesn't matter. So as soon as you have this copy down, we'll do a question. Right, so as soon as you have this copy down, let me know. We'll move on. So Shay, do you think you can only have one pivot?
You could have multiple.
Yeah, you can have multiple. Nice. And I might be going into scary territory here, but if you have a uniform object, the center of gravity will be where? If you have a uniform object, where would the center of gravity be?
In the middle.
Right? And so, where would all of the force be acting on the object then? Well, here was
Where
it, right, Shay? Don't you know that at the center of gravity, that's where the entirety of the force of the object is at. So imagine you have a pencil. If you want to balance a pencil, wouldn't you have to find the center of gravity and support it with your finger?
Yes, sir.
Because at the center of gravity, that's the point where all of the weight of our body acts. So you'll have to keep that in mind for some principle of moments questions. So yeah, you have this copy down?
I just need to write down the x bar, the x equals division thing.
Okay. And Isaiah, as soon as you have it copied down, you'll tell me.
I have everything copied.
Okay, Isaiah, what about you?
I'm done.
Okay, great. This question way too easy, right? Okay, this is a nicer question here. Okay, if I give you all this question to do by yourself, do you think you guys could solve it by yourself? Do you think you could solve this question by yourself? The question is asking you to find for the force here that would cause the system to be in equilibrium. Tell me, do you think you'd be able to figure it out? Or you want me to do this first question with you guys?
You can do it.
You're looking a bit daunting.
Not really, but
Okay, well let's just do it fast, right? So Isaiah, first things first, if it's balanced, the clockwise moments or the anti-clockwise moments is equal to each other. So anti-clockwise moments is equal to clockwise moments. Right? Isaiah, if this is the pivot, right? If that's the pivot, let's consider this side first, shall we? This side over here. Let's consider this side first. So Isaiah, if we have an upwards force, right? Right, Isaiah, you with me?
Yeah.
So Isaiah, imagine you have something being balanced here and you tug on it upwards. Wouldn't it want to go in this direction if you're
But
tugging on it?
clockwise.
She, do you agree? Clockwise?
oh yes, sir. Wait. Yes, sir.
So you could understand that if you have something here on a pivot, right? If you apply a force upwards, wouldn't it want to go in that position? If you
Yes, sir.
if you're pulling it upwards, it will go in that position, right? So this over here, this would be clockwise. So this is actually clockwise, right? Um, so that's one clockwise moment. Let's calculate that one time. So Isaiah, that's a force of 25 newtons and the distance is 0.8 from the pivot. So I am going to say 25 by 0.8. Right, Shay, do you think you could spot any other clockwise moments?
The 27 and the 7N.
The 20 and the 7?
Yeah.
Let me see. Yeah, both of these are clockwise movements. So it'll be plus, you tell me, plus what? Let's do the 20 newtons first. So the force is 20. What's the distance from the pivot? That's the question, Shay. So if this is 2 meters and this is 0.7 meters, what would this distance over here be?
1.3 meters.
Yeah, 1.3. Right? And for anybody that's confused, if the entire distance from here to here is 2 meters, then if I remove the 0.7, that would leave me with the 1.3 meters, which is the distance from the pivot to this force over here. So 20 by 1.3 plus what?
The 7 by the 2 meters.
Right. Isaiah, you okay with everything so far?
Yeah.
Yeah, okay, Isaiah, for the anti-clockwise moments, how much anti-clockwise moments do we have, Isaiah?
Just only have one.
So you have one, right? And that would be this one over here. Because if you exert a force downwards, it would cause the seesaw to go in this direction, which is clearly anti-clockwise. Cool. So that would be a force of X. And what's the distance from the pivot there, Isaiah?
2.2 meters.
Right? 2.2. Right. So you're gonna end up with 2.2x equal to 25 by 0.8. We could just plug that entire thing into our calculator. 25 by 0.8 plus 20 by 1.3 plus 7 by 2. Are you all getting 60? Just confirm you're getting 60.
Yeah. Yeah.
Okay, great. And so Shay, what's next? I want to find for 1x. So what would I have to do?
You'll have to divide the 60 by 2.2.
Yeah.
Or both sides by 2.2.
So x would be equal to what?
27.27.
Oh, are you laughing because it's
Yeah.
27, 27, 27, 27, 27?
Yeah.
That's an interesting fraction, right? Yeah, that's a really interesting fraction. 27.27. And what am I going to put for the units, Isaiah?
Meters.
No, you lose a mark there. Isaiah, you lose a mark there. You just lose a mark. Shay, what are the units supposed to be? Shay, do
What
you
was the
know?
question?
But what is a unit supposed to be?
Oh, newtons.
Isaiah, remember for
Oh,
this
oh,
question,
so CDX and so it was the
distance.
last ones here.
Uh,
I'm mixed up.
I catch you lacking for the first time. That's crazy. You have to look at exactly what the question is asking of you. Right? So copy this down and send the diagram. I want to see how are you drawing on the diagram. For sure, looking forward to see your diagram. Isaiah, you as well. So the next question, I'm going to throw you all into the ocean and let you all fight it out. And we'll see how that goes. Okay, good job, Isaiah. I'm sure I'm waiting on you now. I'm sure. Where you finished? I mean, where you at with the diagram? Are you nearly finished?
I just have one more information to put.
Okay. Yeah, use fancy colors and thing. Okay, okay. Did you finish your work in it yet?
Yeah, I wrote down the working before.
Oh, okay. All right. Um, shit, do you think you'd be able to figure out this question by yourself? Or like that'd be
Uh,
doing too much.
I don't know.
Isaiah, what about you?
It's the same thing, I think.
Okay. Well, let me give you all the question and I'll see if you could figure it out. please look away from it. I'm gonna stop share. Erase the solution. It's okay. All right, so share. We give the question I read.
A uniform rod AB
A
of
rod.
weight
Rod.
of rod my bad, AB of weight 100 newtons and the length 2 meters is supported by 2 vertical strings at its end and carries a load of 20 kilograms as shown in diagram below. Determine the tension of the strings in the strings.
Okay. Let's make sure I have all the information. Any question? All right, do I have all the information? Okay, yes, I have all the information. Right. So let me give you guys some hints. So shape, if this system is in equilibrium, right? What are the two things that must be met for it to be in equilibrium?
Can you repeat? I'm so sorry.
Are you paying attention?
The internet.
Okay. Shape, if a system is in equilibrium, what are the two conditions that must be met?
That it has to have at least something to balance out the 20 kilograms from the other side.
Wait, say that one more time.
That it has to have at least some sort of force or weight on the other side to balance out the 20 kilograms.
That's not exactly what I'm looking for. Looking for the two conditions. There were two conditions I gave you all to copy down.
Or that the counterclockwise has to equal the anticlockwise mom
Right?
moment and
So the
the
anti
downwards force have to equal the upwards force.
correct. So the anti-clockwise moments have to be equal to the clockwise moments, and the upward force need to be equal to the downward force. Okay. Right. So Shay and Isaiah, I'd like you all to give this question a try. So they are saying determine the tension in the strings.
So the tension is the same thing as force?
Say that again?
The tension is the same thing as the force?
Yeah.
Oh,
Tension would be the force felt on the string. What I'm worried about is I just want to make sure that I have all the information there. Let me check one last time. Just make sure I have all the information. Right. Okay, yeah. If I give all of this, that'll be like I'm not supposed to be here. That's one of them. I'm not supposed to be there, right? So, all right. See if you'll come up with anything. I'm giving you all 6 minutes. Right? So Isaiah, if a system is in equilibrium, we know that the upwards forces is equal to the downward forces. Now, you have a uniform rod with a weight, and it's supported by two vertical strings. So Isaiah, if that's the case, the uniform rod will be exerting a force downwards. And so the tension on the string would have to be a force that's going upwards. You understand what I'm saying? Because if the weight would
Mm.
go downwards, then to keep the system in equilibrium, those strings would have to exert an upwards force to cancel off the downward forces. So, she, in this question, how much pivots do you think there are? Tell me, Shay, how much pivots do you think there are in this question?
1.
You think there's one? Ah, nah. Have more than one. Here, what, I really feel like I should do this question with you guys, because this question kind of tricky. So, Shay, you're saying there's only one pivot, right? Isn't that pivot a point about which something could rotate?
Yes.
Okay, Shay, if you were to cut the string, right, wouldn't this plank be able to rotate about this point? So here we're saying again, right? If you cut the string, wouldn't this be able to rotate freely? Like, wouldn't it be able to swing back and forth about that point?
Yes, sir.
So we could treat that as a pivot. And similarly, if I were to cut this, wouldn't the plank be able to swing about this pivot?
Yes, sir.
So there's two pivots. Which pivot do you want to pick, Shane? Pick one.
I think A.
A, okay. A, you want to pick A. First things first, shape. If this is a pivot, right? Um, would this string generate a turning force if it's at the pivot? Yes or no?
No.
No. Because if it's at the pivot, then what is its distance from the pivot?
0.
Yeah. So this would not generate any forces. Isaiah, do you understand?
Yeah.
So Isaiah, if we are saying that this is the pivot, then this string would not be able to generate any turning force because it's at the pivot, the distance is 0. Moments is force by distance. Okay. Right, so clockwise moments is equal to anti-clockwise moments. So Shay, I need you to identify a clockwise moment. So if we're taking this as a pivot, imagine that you snip this string, what's gonna happen?
It'll be clockwise. The B pivot would turn into a clockwise motion.
Okay, so you're saying that it would go in this direction.
Yes.
Yeah. Now you gotta be very careful here, right? Very, very careful here. So Shay, this 20 kg, that would be clockwise for sure. So that would be what? How much force would that be? If it's 20 kg, how much force would that be? That's the first thing you should do. How much force would that be? If something has a mass of 20 kg, what's the force? Should you know to find the force for an object that has a mass of 20 kg?
It'll be times gravity.
Right. Remember, weight is an example of a force. So weight is equal to mass times gravity. The
Which will
mass
be
is 20,
200 newtons.
right? 200 newtons, that's correct. So it has a force of 200 newtons, and it's at a distance of how much away from the pivot?
0.5 meters.
0.5. Tell me, Isaiah, you're understanding everything so far?
Yeah.
Okay. Right? Shay, is that the only clockwise moment?
It has the 100 newtons.
The 100 newtons as well. Now, that force is what distance away from the pivot?
1 meter.
Okay. Now, the question is, are there any anti-clockwise moments? That's the question, Shay. So, we said that, okay, Shay, anytime you attach an object to something, it would obviously exert a downwards force. So you understand that this would generate a downwards force, this would generate a downwards force. But to keep the whole thing up, wouldn't this string need to exert an upwards force?
Yes, sir.
Right. So imagine that you take this and you exert an upwards force. This would want to turn in this direction. So what direction is this?
Anti-clockwise.
That's
Clockwise.
anti-clockwise, right? That's anti-clockwise. And let me ask you a question. Do we know the force on that string? Tell me, Shay.
No.
We don't. We don't know what the force is, right? So we don't know what the tension is. Shay, did you know that tension is an example of a force?
Yes.
Yeah, okay, cool. Right, so it's going to be T2, because tension is a force, multiply by what? Tell me, Isaiah, what's that force's distance from the pivot?
2 meters.
Right. So let's work this out. There's one unknown, so we should be smiling. 200 by 0.5, which is 100, because that's 200 by a half, right? Plus 100 by 1 is 100. And that would be equal to T2 by 2, which is 2T2. Is anybody confused so far?
No, sir.
Okay. What's 100 plus 100?
200.
Right, so you end up with 2T2 is equal to 200. So therefore, T2 would be equal to what?
100
100. 100 what?
newtons.
Right. Was it that hard?
No, sir.
But we're not done with the question yet, but let's try to analyze everything we did so far. So there's two strings. If one of these strings snaps, it would create a pivot about which this uniform rod could rotate. So we decided to take this as the pivot, right? Because this string was at the pivot, we did not count it because it was at the pivot, it would create a turning force of 0. We had a mass generating a force over here, and that would be a downwards force, which was clockwise. Similarly, similarly, we have 100 newtons, and do you think you could figure out why the 100 newtons is over here? And what do you think the 100 newtons represents? That's the weight of what?
That would just be the weight of the rod.
And why is it acting in the center?
Because, well, it's the center of gravity and
Because the rod is?
weight 100 newtons, so it's just pulling down at the center.
Because the rod is uniform. The rod is uniform, that's why it's acting at the center, right? And it's also a downwards force, so that's going to create a clockwise moment. So we're okay with the left-hand side for sure. Now, Shay, you agree that to keep this uniform rod in equilibrium, you would need some upward forces to cancel off with the downward forces. Yes or no?
Yes, sir.
Great. So if that's the case, right? If that's the case, then we would need to consider this upward force over here. Now imagine if you apply an upward force, it would cause this uniform rod to rotate in an anti-clockwise direction. So the anti-clockwise moment will be T2 by 2. So in other words, the the tension on this string here would be 100 newtons. Right. Isaiah, are we done?
Yeah, finish.
Are you saying now we're done with the question?
Um,
Isaiah,
I think so.
we found the tension on one of the strings. Don't we have the tension to calculate for the other string?
Yeah.
So there's two ways we
T1.
could, so there's two ways you could go about doing this. So if you guys want, you could repeat the same process, but just consider this as a pivot this time. Or remember, if a system is in equilibrium, what do we know about the forces? Somebody remind me. If a system is in equilibrium, what do we know about the forces? If a system is in equilibrium, what do we know about the forces?
They would be equal to each other.
What forces will be equal to each other?
The downwards and upwards force.
Correct. So what are the upward forces in this question?
That would be the T1 and T2.
Right? So T1 plus T2. And what are the downward forces in this question?
The 100 newtons and then the 200 newtons.
Right. We know that T2 is 100 newtons, so we made that substitution. And on the other side, we'll have 300 newtons for the downward forces. So therefore, T1 would be equal to 300 newtons minus 100 newtons. So therefore, the tension on the first string would be 200 newtons. Is there anything I did that you all did not understand?
No, sir.
Right, logically speaking, does it make sense that this string has more tension on it?
Yes, sir, because the weight is closer to that one.
Exactly. Isaiah, does that make sense?
Yeah.
And additionally, if you think about it like this. So number one, if you look at the distribution of the masses, it's closer to the left-hand side. And additionally, remember, the greater distance you are from the pivot, you create a greater turning force. And so we have two pivots over here. So wait, that might be kind of tough to explain. But understand the part where most of the mass is over here, so we'll have a greater tension. You understand that one for sure?
Yes, sir.
Okay, I'll leave it at that. I don't want to confuse you guys. If you'll understand that, then cool. So copy this down and I'll do the question one more way. So if instead I decided to use B as a pivot, then I'll be finding for what tension then? In that case, I'll be finding for what tension?
T1,
T1. And we already know that T1 is supposed to be.
200 newtons.
So when we do it back, we're supposed to get 200 newtons. So we'll see. So copy this down, right? And we'll do the alternative way and see what happens. Isaiah, do you think you'll be able to figure this question out in the exam?
I
Yourself?
think I would have stopped up to T2 because I forgot to find for T1.
Okay, okay. What about you, Shay? Would you have also stopped at T2? Would you ever reach that far?
Yeah, I think so.
Okay.
I don't know though.
Right, so as soon as I have this copy down, let me know so we go through the alternative solution.
I finished everything.
Shay, you have like you are you like Flash? That's crazy. You ever watch a Flash series by chance?
No,
Nah. Isaiah, how about you? Did you watch a Flash series?
But
Some parts? Mhm. But what do you think about
I'm
the
done.
okay, you finished? Okay.
Okay.
What do you think about the new Flash actor?
I don't see myself.
Okay, name. A lot of people didn't like him actually.
Is he the one from, I think is Justice League?
I think so. I forgot his name though, but nobody liked
I
him.
think it's Ezra or something.
Ezra Miller. Yeah, Ezra Miller.
Yeah.
All right. So, so Shay, let's see if we fully understand this thing now, right? So Shay, this time around, I'm using B as the pivot. So Shay, if I'm using B as the pivot, can you tell me what kind of turning forces would create? Clockwise or anti-clockwise?
anti-clockwise.
Anti-clockwise. What about this?
Anti-clockwise also.
Right? And this,
Clockwise.
right? So let's just speed around this, right? So we know that ACW is supposed to be equal to CW, right? So that'll be 200 newtons by what? 200 newtons by what? You tell me, 200 by what?
That would be 1.5.
1.5, correct? Plus 100 by,
The same one.
right? And that would be equal to,
T1.
not so fast. If B is a new pivot, what is the distance from the pivot? What's the distance of T1 from the pivot? So
2
if it's,
meters.
yeah, 2 meters. So that's going to be 2 T1. Isaiah, are you seeing any mistakes here? Does everything look good?
Yeah.
Okay. What's 200 by 1.5, Shay?
300.
Right, 300 plus 100 is equal to 2T1. I think you could already see that you're going to work out because you're going to end up with 2T1 is equal to 400. And so T1 will just be 200 newtons. So how you feeling, Shay? Seeing that everything worked out, the alternative method worked out, everything makes sense. How you feeling?
Satisfied.
Yeah, I'm feeling satisfied. I should have no loopholes in the understanding, right? And Isaiah, how you feeling? seeing that everything worked out.
Um, good.
Good, okay. So Isaiah, how would I find for T2 now? If I did the question like this, how would I find for T2? Isaiah, how would I find for T2 next? Isaiah, there.
You'd have to add the downward forces and put it equal to T1 plus T2 and solve for T2.
Yeah. So that would be T1 plus T2 is equal to 100 plus 200, right? T1 is 200 already. So 200 plus T2. And guys, what's the answer we're expecting?
100.
Right. So every single thing checks out. There's no confusion. Is anybody confused by anything at all? Tell me now.
No, sir.
Okay, good. Okay. I would like you guys to try this question. I think everybody here is very capable and you could do this question, right? So a student is trying to measure the weight of a spherical rock below by using a balancing method. Each slotted mass is 100 grams and the hanger is an additional 100 grams. If 4 slotted masses were required to bring the system to equilibrium, calculate the weight of the rock, 500 newtons. The mass of the rock later. I think I had the answers over there. Let me just stop sharing the screen for a bit. Hope I didn't give you all the answers here. My bad. Let me just remove those solutions quickly. Down. Why would I do that? So since that's the case, I'm gonna give all you 2 minutes to solve this thing. It should be a very easy question. Did any of you guys ever participate in like a maths Olympiad or
I did last year and I got distinction.
oh wow. Um that was the Australian Maths Olympiad?
I think it was, mm,
I think it's AMC.
Oh when I was doing it, I did the Australian Maths Olympiad.
I did the Gauss one. That's the Canadian one.
Oh, okay, okay. Right, so given only 2 minutes to figure this out, this is extremely easy. This is a lot easier than the last one. Okay, time is up. Did you guys get through?
I'm
Shit.
just figuring out detention.
Say that again.
Detention.
Are you working on intention? Okay. Isaiah, are you finished?
Um, no, no,
Which part you reach,
I'm
Isaiah?
on part three.
Part three, okay. Any of you guys here that watch crickets?
My friend just
I
went to a
never see
cricket
cricket
game.
before.
Like I myself, I don't see what's so
My
good about it. And a lot
my
of
friend just went to a cricket game last night.
and how was that?
And she really likes cricket. I can't understand cricket, no matter how much you explain to me. I can't understand the rules.
And tell me this thing now. Oh God.
So I never see cricket before. Since
Wow.
primary school, I don't know the terms like runs and like I forget the next word.
We played it for PE. I don't know what I did, but I ended up getting marks. I don't even know what happened.
Like penalties I say I think like penalties. I myself I don't watch cricket, so I can't tell you that much. I don't get the hype. But if you tell somebody that, like, oh my God, you had to like be worried about your safety. Cause like,
They just come here.
yeah, like real bad. Like what bro, it's just a sport. Chill.
I love watching volleyball.
Well, I don't watch volleyball. I watch football though. Football is cool. Yeah. But like,
And tennis is pretty fun to watch. Not to play.
tennis, yeah. You remember that one sport where the people that just like shoot the target? Remember that?
Archery.
Not just archery, like sharpshooting. Sharpshooting.
Oh, I got
Remember that?
excited. I did a competition for archery.
Oh, and you won?
Mm. It was my first competition, so
So like come on, like third.
no, I was in the wrong category, so I came out fifth. I was like against 20-year-olds, so that was like really fun.
Oh, okay. It was kinda out. You had a disadvantage.
Yeah.
All right, so Shay, did you finish your question? Or you're having a hard time with part three?
I think it's like how I don't have the distance. It's kind of threw me off.
It's actually so easy and crazy. So Shay, I want you guys to assume that the string there is attached directly in the center of is attached directly in the center. Assume that.
Okay, then I have an answer.
Yeah. So as soon as you all are done, please send me a weekend.
I think I have answers.
Okay, send it, and I'll tell you if it's correct. Isaiah, what about you? Are you struggling?
Yeah,
You're struggling? Are you getting through?
I'm not sure, man. Part three.
Okay. I swear to God, instead of easy it is, you'll be like, damn. So let me just get straight into it, right? Guys, send me the weekend you have up to this point. Send me working quickly. I didn't get any working from either of you guys yet. Okay, sure. I'm now seeing something. All right, so Isaiah. Okay, sure. Since you got through, I'm mainly going to do this question with Isaiah. So Isaiah, a student is trying to measure the weight of a spherical rock below using a balancing method. So Isaiah, right now, is the scale balanced? Tell me, yes or no, Isaiah?
Yeah.
Yes. Now we're going to make a couple assumptions that this string is in the dead center of this. It could be a plank, whatever it is, right? And we're gonna assume that whatever this is, it's of uniform density as well, right? So Isaiah, exactly the half mark. All right. So Isaiah, for this system to be in equilibrium, we should understand that the upward forces need to be equal to the downward forces. Yeah or no?
Yeah.
Right? So upward forces would be equal to downward forces. And we should also know what tell me, we should also know what? Tell me, Isaiah.
Clockwise movements equals anti-clockwise movements.
Right. Okay, so first things first, right, Isaiah? They're saying that each slotted mass is 100 grams. So how much slotted masses do we have here, Isaiah?
4.
4. So if you have 4 slotted masses, then that alone would be 4 times 100 newtons. And
It's at grams.
oh, it did say grams. If that's the case, Shay, I believe you're
I
right.
have to convert grams to kilograms.
Right. Yeah, you would have to convert grams to kilograms. Shay, did you do that? Did you convert the grams to kilograms, Shay?
Technically, yeah.
Technically, yeah. Let me see what you mean by that. You leave out a good bit of working though. All
I
right.
had to rewrite it really quickly because my working was like really scrappy.
Oh, well, I'd rather see that than just the answers. Right? So Isaiah, if we're gonna convert 100 grams to kilograms, you divide it by 1,000, right? So you divide by 1,000, and that would be equal to what?
0.1 kilograms.
Right? So you'd have to multiply 0.1 kilograms by 4, right? So first things first, this would weigh what's in? This would have a mass of 4 by 0.1 kg, right? And that would be 0.4 kg. Now we also have to take into consideration that this has a mass of what, Isaiah? What's the mass of that?
It's the same 0.1 kilograms.
Right? So altogether, the mass of this entire thing would be 0.4 plus 0.1. So altogether, that's going to be 0.5 kg. So then the weight of the rock. So right now, Isaiah, isn't it completely balanced?
Yeah.
Yeah. I'm going to show you something. So, Shay, remember how you were telling me that you don't know the distance? You remember you were telling me that you don't know the distance? And
Yes, but technically the distance will matter because they're equal.
exactly. I'll show you how that'll look algebraically just now. Right, so Isaiah, logically, if it's balanced, that would mean that this force and this force is the same because that would mean that they're generating a turning force with the same magnitude, just different direction. Isaiah, did I confuse you with that statement?
No.
No? Shay, did I confuse you with that statement?
No, sir.
Good. So if it's balanced, they have the same turning force, it's just different direction. To cancel off now because anti-clockwise moments is equal to clockwise moments. Nice. So the force here would be, so F would be equal to the mass, which is 0.5, multiplied by the acceleration, which would be 10. Right? So the force here would be 5 newtons. Now let me show you something, right, She? And you could do this, but this wasn't necessary. If it's the center, right, She? And I could call this X.
Yes, sir.
Isaiah, and if it's in the center, and I could also call this X again.
Yeah.
Yeah. Now, if it's balanced, we know that the anti-clockwise moments is equal to the clockwise moments, right? And so Isaiah, let me show you how that would look like. So if this is the pivot, right? And there's a downwards force here, that would cause it to move in our direction, clockwise or anti-clockwise,
Anti-clockwise.
right? So the anti-clockwise moment would be X by, we can call that Y. We don't know what our force is, right? You'll see what I'm getting. You'll see where I'm getting with this. So Isaiah, did I confuse you there? I'm saying that the anti-clockwise moment would be equal to the distance from the pivot multiplied by the unknown force. Did I confuse you?
No.
No? Okay. And that would be equal to the clockwise moment. So the clockwise moment would be generated by the force by the distance. So that would be 5 multiplied by x. So is everybody okay up to this point? So I have the anti-clockwise here equal to the clockwise. Is anybody confused?
No, sir.
Right. Isaiah and Shade probably notice that we have the same x term on either side. So if we divide by x on either side, what's going to happen?
Y equals 5.
Yeah, that's the mathematical algebraic proof. Right, so y is also equal to 5 newtons. Shade, would you have thought about that?
No. Why would I want to get algebra involved if there's no need for that?
I mean, if you could do this, it would flex your skills, right? It would show that you have a deeper understanding. And Isaiah, I feel like you might do something like this. Seeing it now, I feel like you might do something like this, right? But you didn't have to do all that, right? You could have just say, since the system is in equilibrium, right? Then weight of the rock would be equal to weight. Yeah, simple. But I would do this to be a little extra. Right? It doesn't kill to be a little extra. Right? So that's part 1. Part 2. Part 2 is saying the mass of the rock that I had. Isaiah, if you want to find for mass, right? Isn't force equal to mass times acceleration, or W is equal to mass times gravity? Isaiah, you understand that? It don't matter which one you use, right?
Mm.
Shade, do
I prefer to use the second one.
you prefer to use the second one?
Yeah.
Okay, but Shade, you understand it doesn't matter which one you're using.
Once you get the answer.
Yeah, and look at this, right? Shade, and isn't weight a force?
Yes.
Isn't gravity a value for acceleration?
Yes, sir.
It really don't matter, honestly. Right? But I'll use this because that's what Isaiah wants. So W is equal to mg, right? The weight of the rock was 5, and 5 is equal to the mass. We don't know what the mass is, and the gravity is 10. If you divide both sides by 10, m would be equal to 5 over 10, which is a half, which is equal to 0.5. right? So that'll be 0.5 kg. I'm presuming everybody got that.
Yes,
Isaiah,
sir.
nice. Isaiah, is there anything confusing you?
No.
No, and the last part, the tension experienced by the string, right? Isaiah, tension is an example of an upwards force or a downwards force?
Upwards.
Upwards. Remember, the system is in equilibrium right now. So the upward forces would be equal to the downward forces. So if that's the case, well, the upward forces here would be equal to, to this, right? This is tension in a string. Could we all see that? And the upward force would be the tension on the string here. Are you all confused by that? Isaiah, are you confused by me saying that this is the tension?
No.
No? Okay, well, good. So the only upward force here is the tension, and the downward forces are, well, I have two downward forces. I have the 5 newtons there, and I have the 5 newtons over there, because both of them are 5 newtons. So the tension is 10 newtons. Isaiah, was the question easy?
Yeah.
Yeah? Okay, cool.
Mm.
So I want to do one more question before we end class, right? So Shay, you see how this is 73 pages?
Yes.
I did this in one night. So the night before the exam, I had a physics marathon and we went for 17 hours. And
That's crazy.
this was the result. I will send it to you guys. It have basically the whole syllabus on anything you could possibly want to know over here, right? Yeah, this is a lovely question. I love this question. Right, so is that the only part for that? And I also have this part as well. Okay. So this is one of the trickier questions. Yeah, it's one of the trickier ones. See if y'all could figure this out. I'm giving you all 10 minutes. May the odds forever be in your favor. Well, if you get through this, are you ready for that exam, you know? Are you ready for that exam? Actually, I had something I told you today that would come in very handy for this question. But I'm not sure if you can pick out what I was talking about. But good luck. Right, guys, any luck? Any luck? Tell me. Shay, Isaiah, any luck at all?
I'm on part two.
You on part two? Shay, you on part two?
Yes, sir.
Well, I mean, Shay, yes, that's crazy, right? You see how easy that 2 marks was? That's ridiculous. I can't lie. That's genuinely ridiculous. Isaiah, in physics, it's just be giving away marks, Honestly, it's just be giving away marks at this point. Calculated weight. 2 marks. Wow. Shay, any luck with hmm, part two? Isaiah, part two. How is part two coming along? Part two is 4 marks.
I'm on part three.
Okay, so Isaiah, you got through with part two.
Yep.
Okay. Shay, what about you? Did you get through with part two?
I'm almost done with part two.
Okay. Okay, 2 minutes remaining. Okay, Isaiah, so I had to find a harder question for you. Is it that you did the question already?
No,
No, okay. Maybe you're correct. Isaiah is a boss. Big up you. Isaiah, I really think you're ready for the exam, you know. You're gonna write the exam in January?
yeah.
Yeah, you're gonna get one. If you don't get one, the system is broken. What about paper three? Are you ready for that?
Paper three physics.
Yeah.
I didn't do a paper three as yet.
Never.
Only paper ones and twos.
If you wanna get one, you have to focus on that, yeah?
So like I have the answers, but like my work is really scrappy.
It's okay, same thing.
Also, I don't know what to like label X on the diagram, but number two.
Hmm. Let me see what you have here. But she got it correct as well. Did you do this question ever? Like, was this the first time you did the question?
No, but like I skipped so much working with like the X and stuff.
And this is your first time working the question.
Yeah.
Okay. Well, let me show you the proper working, right? But I'll hear real smart way. So figure six shows a uniform meter rule balanced horizontally on a fulcrum with a mass of 0.24 kg hanging from one end. Before we do anything here, she, it's a uniform meter rule. Where would all of the mass act?
In the center.
Exactly, at the center. So at the center, I'm going to draw an arrow, and that would be the and that would be the weight of the meter rule. Did I confuse you?
No, that's just all I needed for the working.
Right, and that would be the center of gravity, right?
Yes, sir.
Great. And we could call that X newtons. Cool. Um, Calculate the weight of the 0.24 kg mass. That really easy, right? Weight is equal to mg, and they told us to use G as 10 newtons per kg. Cool. So that's going to be a mass of 0.24 multiplied by 10. And that should be equal to 2.4 newtons. Everybody got that, right?
Yes, sir.
Cool. By taking moments, calculate the weight of the meter rule. Again, that question is 4 marks. Look how much space is left. Are you seeing that? Isaiah, are you seeing this?
Yes,
It's so
crazy.
it's so easy to get a distinction in physics, actually. Like, oh my God, it's so easy. One of my students did physics. He's a grown man, right? Like 28. No, no, it was 30. I don't remember, but he was like in his 30s. Um, never do physics in however long. He do physics in 3 months and he got two. He got a two. Yeah. So sure, you're gonna get a distinction in physics, right? Like no problem.
Um, sure.
Come now. Yes, say yes. Distinction for sure.
For sure, for sure.
Cool. So we're gonna take moments now, right? Now here's the thing. Let's check out something, right? So figure 6 shows a uniform meter rule. It's a meter rule, guys. If it's a meter rule, what's the length of it? It's in the name. Shit, if it's a meter rule, what's the length of it?
1 meter.
1 meter. You know how much people they're gonna fly over their heads? So much people. And if it's 1 meter, then the center of gravity would be at 0.5 meter. Yeah or no?
Yes.
Yeah, because it'll be at the center, right? It's a uniform Planck. And if we know that this is 0.18 meters over here, then to figure out the distance of the center of gravity to the pivot, how would I do that? Tell me, Shay.
You minus the 0.18 from the 0.5.
Right? And that'll be 0.32. Yeah? I do that mentally. I'm not sure if that's correct.
I got that.
Okay, great. So we not get right? Now, if we are considering this to be the pivot, and you apply a downwards force over here, it's going to cause the Planck to move in this direction. And that direction will be anti-clockwise. Yeah? Yeah or no?
Yes, sir.
Okay. And let's just confirm that. So again, if you were to push the Planck in this direction, look at how the Planck is going to move. It's going to move in this direction. Yeah, right? So anti-clockwise is equal to clockwise moments. So that's going to be 0.24 by what? What is the distance from the pivot there?
The 0.32.
Nah, watch. So do you understand this will be anti-clockwise? Watch.
Oh, the 0.18.
So this is anti-clockwise, right? Because
Yes.
clockwise would be in this waiter, right? 0, right? It would be going in this direction. If I apply a force over here, wait. Yeah, and this is clockwise, guys. Like, honestly, I'm losing my mind. That's clockwise, right?
Yes, that's clockwise.
Okay, I thought I was losing my mind there, right? And this would be anti-clockwise because it's going in the opposite direction, right? Now, Shay, I'm asking that because in your working, uh, I think you leave out a good bit of work in there. Like, wow, that was a lot of work you leave out. But to get 0.432, I'm guessing you would have said 0.24 by 0.14.
Yes, sir.
Okay, that's the only anti-clockwise moment there. And the only clockwise moments we have would be the weight of the meter rule. If you're applying a downwards force in this direction, it would generate a clockwise movement, right? So that would be x multiplied, and the distance from that would be 0.32. So, Isaiah, you have all of this, right?
Yeah. Yeah.
Okay, great. So you'd end up with 0.432. Did you all get that?
Yes, sir.
Wait, that would be 0.18. Yeah. Then who I get 0.14 from? Right, and that would be equal to 0.32x. Now, if I want to find for x, I would have to divide both sides by
0.32.
0.32, right? Shay, do you know that?
Yes, sir.
Okay, 0.432 divided by 0.32 is
1.35 newtons.
right? Bam, that's it. Right? Calculate the mag. So like, okay, guys, was that hard? Was that hard at all? Tell me.
Food.
That was easy, right? Shit, that was easy, right? Like,
Yes,
you
it's
have,
just working.
yeah, you had to work on your working, right? You had to work on your working. Yeah, you use real rush stuff. I'm gonna send Isaiah's working. Isaiah's working is like peak. This is like, you want to get full marks? So we should have. Right? Calculate the magnitude of the force of the fulcrum acting on the meter rule. Right? So the fulcrum is over here. So tell me, Isaiah, wouldn't the fulcrum meter exert a force that's upwards that's equal to the sum
Yeah.
of downward forces?
Mm.
Right? So over here we have 2.4 newtons. And over here we have, that was 1.35 newtons. So altogether, the force exerted by the fulcrum is what? 2.75, right?
Yeah.
Yeah, because upward forces is equal to downward forces. Right? So, right. So that force would just be equal to the 1.35 plus the 2.4. All right, that'll be 3.75 newtons. So guys, are we ever going to get any moments question wrong?
No.
No. Shay, are we going to lose that? How much marks are it? That's like at least 8 marks. Are we gonna lose 8 marks in the physics exam?
No.
No. Gonna get a 8 marks for sure. Right? Yeah. Isaiah, let me check where you send there. Isaiah, you find that question was hard. I find that question was easier than this one. And matter of fact, Isaiah, watch. Since you're talking about that question, watch. Watch Isaiah. I'll be right here. And that's the question you're talking about.
Yeah.
Yeah. This is my working. Because she look real shiny, yeah? This person look real shiny.
She looks like the doll from Squid Games.
Oh my god. Oh my god. I see it. Boku, I don't know the full, I know I'm slaughter the pronunciation, but she look real shiny. When I was doing the marathon, I was like, hey, look at this girl looking real shiny. And everybody agreed with me. So yeah, Isaiah, let me check your working quickly.
So I find the first question simpler.
Find the first question simpler. You see, with this question, right? Plenty students not gonna remember that. Like, okay, be real. How much students you think gonna remember that the weight of an object acts at the center? Not a lot. A lot of people are not going to remember that. This question requires more application and connecting the dots. I would not say that this question is harder. This question will be easier in my opinion. I like this question. I just think it's easier to solve if you know what you're doing. But with this question, you have, again, and you have to know that the center of gravity is the point at which all of the weight of an object acts. You need to know that.
Yes, sir.
If you don't know that for this question, you're cooked. You're really cooked. All right. So that's it for class today. I will send the Squid Game Girl question for homework. All right. Did you decide if you'll be continuing when school resumes?
Yeah, so it basically I don't have an answer yet because my school, like my teachers and stuff might be doing lessons and stuff, and I want to find out the schedule for that because it would be easier for me to just stay back.
Oh, okay. Yeah.
Yeah. So I don't have an answer yet. I'm sorry.
Okay, that's not a problem. Well, I'll still send the question. You could try it if you want and send it to me. All right. So yeah, guys.
Hmm.
Hope you all have a blessed evening and see you guys when school reopens. Later, everybody.
Bye.
I see.
Bye.